Now, let's move into something that's a little bit more difficult, factoring trinomials. Now, in the process of factoring trinomials, assuming that we cannot factor out a common monomial first, we are going to have to break a trinomial up into two smaller binomial parts. Now, you can read through the beginning paragraph and see that when we do this, we're basically going to be breaking it up into going from a trinomial to start and finishing with two binomials to finish in the factoring process. Now, there's a pattern that takes place here that you're going to have to become aware of. The outside term, the constant term, is going to be a result of the products of the two binomials, and the inside term is going to be equal to the sum of the particular variables from the binomial. So we have to come up with a list of potential pairings that we could use that would make a product and a sum given the m and the n values from the binomial. So what we want to do when we work a problem like this, and we're going to start by clarifying that we are only going to be doing this with a trinomial that has an understood 1 as a leading coefficient. That's a very important part of this, because when we have a number greater than 1 for the leading coefficient, we're going to go through a different process called grouping that we'll discuss later in the video. But we want to focus on right now our leading coefficient will be equal to 1. So here, if you look at this first example, example 2, we can see that we have the number 28, or better yet, we have the value negative 28. We want to come up with all of the possible combinations of numbers that would multiply together to give us a value of negative 28. And so if we did this in table form, you could see here we've come up with all of the factors of negative 28. So negative 1 times 28 is a negative 28. A positive 1 times negative 28 is also negative 28. And so forth and so on until we come up with every single pair of factors that multiply to get negative 28. Then we want to look through that list of factors, and we want to see which set of factors, when added together, would give us the negative 12. And so we're looking for two parts here. We're looking for the m and the n that could give us a negative 28 when multiplied together, and the m and the n that could give us a negative 12 when added together. And that particular situation is only satisfied with one set of numbers. That is the 2 and the negative 14. So what happens here is we can take the 2 and the negative 14 and use those in our binomials, and you can see that the x squared minus 12x minus 28 factors into two smaller parts of x plus 2 and x minus 14. Now, if we wanted to check this and see that we did this correctly, we would simply take the two binomials and then FOIL them back together. If we did this properly, the FOIL should bring us back to the original trinomial. So x times x is x squared, x times negative 14 is negative 14x, 2 times x is a positive 2x, and 2 times negative 14 is negative 28. If I combine my like terms, that gives me x squared minus 12x minus 28, which we see was our original trinomial. So that clearly gives us some indication that we factored each of these, it factored this trinomial properly to the two binomials necessary. Now, the more and more factoring that you do of trinomials with the leading coefficient of 1, the better you'll get at recognizing the factors that multiply to give us the constant term, and then add together to give us the middle term. So this is an experience situation that requires you to get lots of practice, which we will do in class. It's very important that you do this and learn how to use your calculator effectively as well, so that you can quickly determine the factors that multiply to get the constant term. So if we look at the sample problems, sample problem 2 has two trinomials with a leading coefficient of 1 that we ask you to factor. So what we're going to want you to do is to come up with all of the factors of negative 48 for sample problem part A that would multiply to give us negative 48 and also add together to give us negative 2. So go ahead and pause the video at this time and work sample problem number 2 part A and B. Okay, let's take a look at this. Hopefully you've given both of these problems a good shot. If we're looking at this and we're making a list of factors, we start off with probably the most obvious parts. So I know that 1 and negative 48 are going to multiply together to give me a negative 48. But it's clear that whenever I do negative 48 plus 1, that's going to give me a negative 47, which is nowhere close to the negative 2. And of course I could always give the negative part to the 1 and the positive part to the 48, but that still gives me nowhere close to the negative 2 when I add those parts together. So this is where you can learn to use your calculator effectively and quickly. What I can do is I can go to my calculator and I can simply start by looking at the different factors of 48, and I can start this off by doing simply the next number. So 48 divided by 1 is 48. I've got those two numbers, so then I can move to 2. So I could say divided by 2, and of course I'm going to use a decimal, and that gives me 24. So that would give me the next set of terms. I would know that 2 and negative 24 would also give me a negative 48. But again, when I add those two together, it gets me nowhere close to negative 2. So what I'm going to suggest to you is this. Instead of having to write down a full list of factors, it would probably be best if you could quickly roll through these factors on your calculator. So I can do 48 divided by 4. I know that 48 divided by 3 is not going to be an even number, so I'm going to skip to the next number possible, which would be 4, and that gives me 12. So then I have to think to myself, is there any combination of 12 and 4 that would give me a negative 2? And I would see that that is not the case. So then I go to the next number. 5 would not give me an even number, so I need to go on to 6, which gives me an 8. And then here we have a situation where we have the possibility of getting a 6 and a negative 8, which would give me a negative 2. Now you have to be careful with signs in this case, which we could also have a negative 6 and a positive 8, so you would have to kind of make the distinguishment between these two values as to which one would give you a negative 2 when you added them together. And so when we do this, a positive 6 and a negative 8 gives me a negative 2 as a middle term. So I will simply take these two and break them apart. Now, we've been focusing most of our attention here on the negative 48, but keep in mind the x squared is going to be broken apart into two individual parts as well. And so what happens here, that breaks up into x and x, and we can see that the negative 48 is going to break up into a positive 6 and a negative 8, which is going to give me my two smaller binomial factors. Now, a lot of students have difficulty with this at first because they say, where did the negative 2x go? It just disappeared. And in essence, the negative 2x has been broken apart because the trinomial is getting split into two binomials, and that middle term is in essence going away. But a quick foiling of x plus 6 and x negative 8 would get you back to x squared minus 2x minus 48. So Do not let the disappearing middle term alarm you. That is supposed to happen. So you can see I've gone through the slower process of writing out all the factors here, but what I would suggest to you is to become very proficient with your calculator and be able to do this a little bit faster, and then as you do more and more problems you will be able to do most of this in your head. So as we look to sample B, I've got x squared minus 9x plus 14. So it's clear that this is going to break up into two binomials, and x, because it has a leading coefficient of 1, x squared is going to break up into 2x's quite simply. So then we need to focus on the outside number of 14. Now 14 can be broken up in a couple of different ways. We've got 1 and 14, which does not give us a combination of -9. So we need to come up with a situation where we could have two numbers that multiply to give us a positive 14 but give us a negative middle term. So this is a little bit different and a little bit trickier. Now the only other numbers that multiply to get 14 would be 7 and 2, but we need to take a careful look at this. I could have a positive 7 and a positive 2 that multiply together to give me a positive 14, but that's not the only situation that I have. I could also have a negative 7 and a negative 2 that could multiply together to give me a positive 14. So then it's my job to determine which sets of these numbers could be added together and give me a negative 9x. And in this case, it is the two negatives that add together to get the positive. So I could take a negative 7 and a negative 2. And when I have x minus 7 times x minus 2, I've then factored the trinomial to its two smaller parts. And again, if you wanted to check this, you could simply refoil these numbers back together, and it should come out to be x squared minus 9x plus 14. Now, a quick word here. I've been listing sets of numbers here that could be possible factors for our trinomials. Do not get these confused with ordered pairs. This has nothing to do with ordered pairs at this point. It does not represent anything on a graph. This is just me listing sets of numbers to give me guidance for my factoring. So these are the examples in factoring trinomials that have a leading coefficient of 1. So keep in mind that when we have a leading coefficient of 1, this would be the process that you would want to use in factoring.